Okay, the next problem I'm going to do for you is this heat capacity problem number 55 that tricked a bunch of people. But we have 6.79 grams of methane, and it has a heat of combustion of 8.02 kilojoules per mole. And they put that in a calorimeter, and so there's my methane, like that, it's gas. And all the heat from the methane goes into the calorimeter. So they want to know the heat capacity. We know specific heat is joules per gram degrees Celsius. But heat capacity is a term used for just a calorimeter. And if it's a specific calorimeter, it has the same mass every single time we use it. It's a specific tool, and we actually don't care about the grams. So what we're going to have is units of joules per degree Celsius. Heat capacity is joules per degree Celsius. So I have to look at my units. I have kilojoules per mole. There's my degrees Celsius. So somehow I'm going to use these two, but I have to get rid of the moles first. So hopefully you guys are thinking about your first step has to be to get rid of those moles, and you can do that because you have grams here. So if we take 6.79 grams methane, this methane is CH4. Okay, methane and CH4 are the same thing. So it has 16 grams in 1 mole, and then for every 1 mole, it gives off negative 802 kilojoules. Okay, so when you do this, you're going to find, for number 55, 340 kilojoules. Now it's negative because it's given off by the reaction, but we want it to be 340 kilojoules positive absorbed by the calorimeter. Okay, and the last thing we needed to do was we want kilojoules per degree Celsius, so we divide by 10.8, and you're going to get an answer of 31.5 kilojoules per degree Celsius. And you could change that to joules by multiplying by 1,000. Okay, I'm sorry it's really small down there. Okay, that is the specific, like the heat capacity of this specific calorimeter. So we can use it to do this next problem. We have the C2H2, and we know that the Q equals MC triangle T. Okay, well, we don't care about the M. Okay, and that's going to throw you guys off why we don't care about the M. The M is not that mass of grams. It would be the mass of the calorimeter. So instead of this term here, we're going to use just the kilojoules per degree Celsius. And if we multiply by degrees Celsius, we're going to get just the kilojoules. Okay, do you see the difference? When a calorimetry problem comes up, we don't care about the mass of the calorimeter. Okay, so we have the kilojoules per degree Celsius, 31.5 kilojoules per degree Celsius, times the change in temperature, 16.9 degrees Celsius, and you're going to find that that is equal to 532 kilojoules, which is the heat given off by that many grams of substance. So we want kilojoules per mole. Well, how many moles do we use? We have to do 12.6 grams C2H2, divide by the mass of C2H2, okay, which is 26.04 grams in 1 mole. And then you'll take that number, whatever number you get here, and you divide that many kilojoules by that number. So 532 divided by that number, and when you do that, your answer is going to be 1.10 times 10 to the third kilojoules per mole. Okay, and it would be negative because that's the heat released from the reaction. Okay.